So on packet pages 5 through 8, it does use the things that we talked about on Friday. So it does use that you're changing everything to sine and cosine version, that you're making sure that you find those common denominators, but it's also adding in using sine squared and cosine squared to solve problems. Okay, so I've listed the different versions here. So it could be that you see sine squared plus cosine squared. Well, that equals 1. You could see 1 minus cosine squared, which is sine squared. So all I did is I subtracted cosine squared from this side to get this version. And it could also be then that you subtract sine squared to get this. So if you see this, they want you to change it to cosine squared. Okay? So that's going to be the new piece that you see today as you go through these problems. Yes? Yeah, I can put those up again. So the 4 equations are that secant of x equals 1 over cosine of x, that cosecant of x equals 1 over sine of x, that tan of x equals sine of x over cosine of x, and cotangent of x equals cosine of x over sine of x. Okay? So when you see this left-hand side, you need to change it to the right-hand side version. Okay? All right. Are we ready to try some out? So remember, you're only working on the left-hand side. And remember, the first thing that you should always be doing is change any versions that aren't in sine and cosine. So this is cosine squared, we're good there. But tan squared of x needs to be changed into sine and cosine. Since tan is squared, if we square tan on this side, it means both of these are going to be squared on that side. Okay, so we're going to change this to 1 minus cosine squared of x times sine squared of x over cosine squared of x. And we're looking for that to equal cosine squared of x. Before you look into common denominators, you should always see if something cancels. Okay, so do you guys see how the cosine squares cancel each other out? And so you are left with 1 minus sine squared of x equals cosine squared of x. Well, isn't that one of the things we had above? That 1 minus sine squared of x is equal to cosine squared of x. And so this is equal to that, and we're done. And we have just proven this to be true. No, it's always true. Yeah. So they call these identity theorems when you can change it from one thing to another. Is there any questions about the process that I went through there? Anything not make sense?
If it's squared and it's a fraction, is it always going to be the top fraction of both squared?
Yep. And so if you get like secant squared, well, 1 squared is still 1, right? So it's going to be 1 over cosine squared because of that. All right. So here's the next version that we have. We have sine of x minus cosecant of x equals negative cotangent of x times cosine of x. We only do the left-hand side, yep. So first, we need to change what? Cosecant. Good. So we have sine of x minus 1 over sine of x equals negative cotangent of x times cosine of x. What do we have to do next? Nope, because they're subtracting. Common denominators. So for common denominators here, I'm going to multiply this first one by sine of x over sine of x. Since the bottom of this first one is 1, if I multiply this and this by 1, it doesn't change anything. And so then what you have is sine squared of x minus 1 over plain old sine of x. Because remember, when you find those common denominators, the bottom stays the same. It's just the top that gets changed and combined. We want this to equal negative cotangent of x times cosine of x. Okay. So if we look above, the version above, I'm just going to zoom really far out. The version above is that 1 minus sine squared of x is cosine squared. This, though, is sine squared minus 1. It's backwards, right? Okay. So let's change it into the forward version, which would be a negative 1 plus sine squared of x over sine of x. Okay. And then, do you guys notice how the signs are just switched from this version? And so when the signs are switched, it means that it's going to be a negative 1 minus sine squared of x. Okay, so it means that I can factor out that negative. Okay, factor it out, opposite of distribution. So if I factor it out, do you guys see if I distribute it back in, I'd get back to here? Okay, so if your signs are different, okay, but it matches what you see up there, you can pull out a negative, okay, which is where this negative is going to come from. Does that make sense? So usually if you see a negative on this side, you're going to have to do this factoring piece. So then, this is over sine of x. This equals what then? Equals cosine squared. So I'm running out of room. So this is going to be negative cosine squared of x over sine of x. And we want this to equal negative cotangent of x times cosine of x. And this is where most kids get stuck. Okay? Does anyone see what we can do to the top to get it into that form that's on the right?
Well, cotangent equals sine of x.
Yep.
We have cotangent times cosine.
Yep.
Negative cotangent over sine of x times cosine.
Yep. And so what you can do here is, since this is squared, you can write it down twice, correct? That's what something squared means. So then you have negative cos of x times cos of x. And I'm just going to put sine of x under 1, okay? It could go all the way and under both, but it kind of defines it as what we're going to see here. That one of the cosines is by itself, and the other one can be changed to just cos over sine. Well, cos over sine is this cotangent, correct? So then we have negative cotangent of x times cosine of x equals negative cotangent of x times cosine of x. Okay? So again, for most people, this is where they get stuck because they forget if it's squared, we can write it twice. All right? So if it's squared, we write it twice, we go from there. Any questions on that? All right. To me, that last one we did is the hardest. Okay? That's the one that kids get stuck on the most. Okay, so we're going to try this one out now. So we want tan squared of x times secant squared of x. What should we do first? Flip tan into sine and cosine. What about that cosecant? put it into sine. And so we're going to have sine squared of x over cosine squared of x plus 1. I'm going to put that in parentheses, and then I'm going to write my division like this. Okay? Because whenever I have this multi-level fractions, I like to change it into this other division sign. Okay? So then we have cosecant, so that's going to be 1 over sine squared of x minus 1. Okay? And then I'm just going to remind you, this 1 on top actually did get squared, but 1 squared is still 1. Okay? So now that I have that down, what do I have to do individually in each grouping? I have to find what? Common denominators. Good. So I have to multiply this by cosine squared over cosine squared, and I have to multiply this by sine squared over sine squared. Okay, so each grouping has its own common denominator. So cosine squared over cosine squared. This gets me sine squared plus cosine squared over cosine squared divided by, and then this is sine squared over sine squared. So I'm dividing by 1 minus, what?
Cosine squared times cosine squared still cosine squared.
Where?
Times the top and bottom by cosine
Yep. So 1 times cosine squared is cosine squared. The bottom is cosine squared. And then remember, when the bottoms are the same, they just stay that. Okay, like 1/7 plus 2/7 becomes 3/7. So here's what we have so far. Change it. Actually, instead, before we do that, let's simplify this. What is sine squared plus cosine squared equal to? 1. Good. That's equal to 1. And what's 1 minus sine squared equal to? Cosine squared. So let's change that first, just because then we're not copying all this stuff down as we're going through. So then we have 1 over cosine squared of x, okay, divided by cosine squared of x over sine of x, sine squared of x. And then now we can flip that. So we have 1 over cosine squared of x times sine squared of x over cosine squared of x. What is 1 over cosine squared equal to? It's equal to secant squared. What is sine squared over cosine squared equal to? Tangent. So right now in this order we have this, secant squared of x times tan squared of x. And what's the last thing we need to do then? Just need to use the commutative property and just change them, right? And then that gets us the version we wanted. Remember, on your test, what you're going to see is, I'm going to give you this side, and it's going to be multiple choice. I'm going to say, what does this end up equaling? Okay? So it's going to end up equaling one of 4 things on the bottom.
Wait, so you only have the left side?
You'll only have the left side.
Aw, nards.
Okay? So if you do get to like this point, you can be like, oh, it matches this. You don't have to rewrite it, switch. You don't have to do like the easy stuff if you can see which one it ends up equaling. Okay? And it'll follow the process of change it to sine and cosine versions. Once you get it to sine and cosine versions, find common denominators. Once you find common denominators, see what you have to change to get it to that other side. Okay? So you're going to do pages 5 through 8. 5 through 8 covers these 3 concepts. If you want to start working on pages 9 and 10, you can. Okay, but you might get stuck because there is one new part for 9 and 10 that we haven't covered yet. Okay? Yes, you can go get your sweatshirt.
Can we go to school on Friday?
This Friday, yes. Next Thursday, no.